everyone. It's 2:42 a.m. September 9, 2024, and we got a question here that needs to be answered. Let's remove all of this first. Let's remove that, and we're gonna add uh, read me dot md. MD stands for markdown. Okay, so we're going to answer question number one. Oops, question number one. Which method can be used to execute a garbage collection and may free memory resources within the managed heap? Then when there is memory to free. Okay, my answer for this is gc dot finalized. My my .NET fundamentals are very rusty. Let's check if that is correct. Let's open up ChatGPT and did it. Alright, so let's type this question. Let's put this here in the question to ChatGPT. Let's put it here. The method that can be used to, oh man, I'm wrong. Yeah, right. So the method that can be used to execute garbage collection and potentially free memory resources within the managed heap in .NET is jc.collect. This method forces garbage collection to occur. Yeah. What am I thinking? They are just going to collect when when called, it attempts to reclaim memory by collecting objects that are no longer in use and freeing up memory in the managed heap. However, it's generally recommended to let the .NET runtime manage memory automatically, as explicitly calling jc.collect can lead to performance issues if overused. The garbage collector in .NET usually runs on its own based on certain conditions, like when the system is low on memory or when the heap gets full. Yeah, that is only when the garbage collection triggers. Garbage collector in .NET usually runs on its own based on certain conditions, like when the system is low in memory and when the heap is full, gets full. So usually the garbage collector just sitting pretty if your memory is it's a lot of space, and if it's almost running out of space as stated here, running low on memory, yeah, that is when the garbage collector gets triggered. So my answer here is wrong. Damn. Oh yeah, that should be jc.collect. JC. I haven't called garbage collector like manually. I haven't like in actual work. Um, yeah. Garbage controller. How do you call the garbage collector? After jc.finalize, suppress finalize. What is the suppress finalize? Request that the common language runtime not call the finalizer for the specified object. There is no argument given that response. Yeah, if you want to suppress that, you don't want the garbage collector to not to call the finalizer. What is the finalizer again? Yeah, so in .NET, what is the finalizer? In .NET, a finalizer is a special method that is used to perform cleanup operations on unmanaged resources before an object is reclaimed by the garbage collector. Special method that is used to perform cleanup operations on unmanaged resources. Cleanup operation on unmanaged resources before an object is reclaimed by the garbage collector. It is called automatically by the garbage collector when an object is no longer accessible, but it's not guaranteed when or even if it will be called. Finalizers are defined using the class name syntax in C#. They are also referred to as destructors, though they work quite differently from destructors in C++. Yeah, yeah, this is the finalizer. Um, but right, so um, yeah, there's another question like if given like given this scenario gc.collect gc.collect uh, variable jbx um, is not being used anymore. gc collect uh, first gc collect, second gc collect, third gc collect. When is the variable jbx gonna be removed from the heap? The variable jbx will be removed from the heap after the garbage collector identifies it as no longer in use and collects it. Let's break down what happens in the scenario provided. First, jc.collect. When jc.collect is called for the first time, the garbage collector will perform a collection and tries to reclaim memory for objects that are no longer being used. If variable jbx is no longer referenced or is in use at this point, it will be marked for collection. However, if variable jbx has a finalizer distractor defined, it won't be immediately removed. Instead, it will be prompted to a finalization queue waiting for the finalizer to run. If it has a finalizer defined, it won't be immediately removed. Okay. So if there's a distractor on a variable or a class, then the garbage they will not be part of the garbage collector's job. They will be in a queue, the finalization queue. Okay. So JC and second JC did collect. The second call to JC collect might trigger another garbage collection, but if variable JBX is still waiting in the finalization queue, it won't be collected just yet. Instead, the finalizer for JBX will run during this phase. After the finalizer executes, if one is defined, the object will be considered ready for actual removal in the next JC cycle. Third, JCCollect if the object has no pending finalizer or the finalizer has already run during the previous collection cycle. The third JCCollect will remove variable JBX from the heap. Summary: if the variable JBX has no finalizer, it may be removed during the first JC collection. If the variable is a finalizer, it will typically be removed after the second or third JC collector, as the finalizer will run after the first or second collection and the object will be finally removed in the next collection cycle. After calling JC.collect multiple times forces garbage collection at each point, but finalizers introduce an additional step before the object can be fully removed from the. Um, what if the variable JBX is still being referenced um, in the first and second JC.collect? If variable JBX is still being referenced during the first and second collect calls to JCCollect, it will not be removed and collected and removed from the heap. Here's how this works in detail. First, JCCollect: if variable JBX is still referenced, the garbage collector will identify it as an active object that is still used. The garbage collector only collects objects that are no longer referenced and reachable. Since variable JBX is still being referenced, it will be skipped and its memory will not be reclaimed. Second, JC.collect: if variable is still referenced, the same process will occur. The garbage collector will again set the variable JBX is still in use. See that the variable JBX is still in use. It will be kept in the heap. Third, JCCollect: if by the third JCCollect variable JBX is no longer referenced, example, the reference to it has been removed or gone out of scope, it will be eligible for collection. The garbage collector will then remove it from the heap during this run, assuming it has no finalizer or that its finalizers has already run. As long as an object is referenced, it is considered alive and the garbage collector will not collect it. The garbage collector operates on reachable objects, meaning any object that is accessible via any chain of references is in your program is considered in use and won't be removed. Thus, if variable JBX is still being referenced during both the first and second JC.collect, it will remain on the heap and will only be collected after it becomes unreachable and JCCollect is called again. Alright. Okay, that's it. Is there any garbage collection in um, Node engines? Yes, Node.js has garbage collection, which is managed by the V8 engine, the JavaScript engine developed by Google that powers both Chrome and Node.js. V8 provides an automatic garbage collection system that frees up memory when objects are no longer needed. This system uses several garbage collection algorithms to manage memory efficiently. How garbage collection works in Node.js, V8, automatic memory management, like many modern programming languages, JavaScript, and thus Node.js does not require manual memory management. Objects are automatically created and destroyed as needed, and when they are no longer referenced, the garbage collector reclaims their memory. Mark and sweep algorithm. V8 uses a mark and sweep algorithm to perform garbage collection. This algorithm works by marking. It starts by marking all objects that are directly reachable from the root, such as blah blah blah. Sweeping. Once it has marked all reachable objects, it sweeps through the memory and reclaims any memory used by objects that were not marked as reachable. Generational garbage collection. V8 employs a generational garbage collection system which divides the memory heap into two regions, the new space and the old space. New space, this is where newly created objects are allocated. The garbage collector frequently checks this space, as most objects have a short lifespan. Old space, objects that survive several collections in the new space are promoted to the old space. The garbage collector checks this space less frequently because this object tends to live longer. Incremental garbage collection. Tuning garbage collection in Node.js. Okay, so if my Angular application is already deployed in production server, example in a um, in a EKS container, can you please explain if the garbage collection of V8 still works when the my Angular Angular application is being used. Yes, the VH garbage collection still works for your Angular application when it's deployed in a production server such as an AKS container. Here's an example of how this works. Angular and V8 garbage collection. Angular applications run in the browser, and modern browsers like Chrome, Edge, and others are powered by JavaScript engines such as V8 for Chrome and Chromium-based browsers. The garbage collection system of V8 is what manages memory for your Angular application while it is being executed. When users interact with your Angular app, regardless of whether it's deployed in an EKS container or any other hosting setup, the app runs on the client's browser, and memory management is handled by the client-side V8 engine or another JS engine depending on the browser. V8 garbage collection in the browser handles cleaning up unused memory such as DOM elements, JavaScript, variables, and objects once they are no longer referenced by the application. Server-side AKS consideration. If your Angular application has a Node.js backend running, no, we are not interested in that. In this case, you have two distinct environments, client-side. The Angular application runs in your users' browsers, and each client's browser handles its own memory management with its respective V8 engine. What happens during production use when users access your Angular application from their browser. The browser's V engine manages memory on the client side, performing garbage collection regularly. Memory, blah, 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 Um, can you set an Angular example where it gives memory leaks? Memory leaks in Angular or any web application occur when objects that are no longer needed are not properly released, causing unnecessary memory consumption. A common source of memory leaks in Angular application can come from improper handling of subscriptions, event listeners, or re references to DOM elements. Here's an example of a memory leak in Angular application due to unhandled subscription to an observable. Example, memory leaks due to unsubscribed observables. Let's say you have a service that provides some data using an observable, and your component subscribers subscribes to it but never unsubscribes when the component is destroyed. This will cause a memory leak because the subscription remains active even after the component is destroyed. Observable internal. Okay, simulates an observable that emits values every second component. So yeah, subscribing to it. This will not complete because this is like it just keeps on emitting. So what's happening here? This component, we're subscribing to an observable that emits value every second. However, we are not unsubscribing from the observable when the component is destroyed. When the user navigates away from the component, it removes the DOM. This results in memory leak because the subscription remains active in memory even after fixing the memory leak. Using take until with subject. Yeah. Okay, other common sources of leaks. Event listeners, adding event listeners directly to DOM elements or services without cleaning up can cause memory leaks. Always remove event listeners on ng on destroy if manually added. Set intervals, not clearing timers when with clear interval, improper DOM manipulation, direct manipulation of DOM outside of Angler's control, jQuery element ref can lead to memory leaks if not handled properly. Conclusion, memory leaks can occur in Angular applications if observable events listener or other resources are not properly cleaned up. In this example, failings. Uh, how to detect a memory leak using Chrome for given uh, an Angular example. Detecting memory leaks in Angular application using Chrome DevTools involves several steps. You can use Chrome built-in tools to identify and analyze memory usage, including snapshots, heap profiling, and monitoring memory allocations. Here's how you can do it. Open Chrome DevTools, right click on Angular application and spec, blah blah blah. Use the performance tab. The performance tab can help you identify issues related to memory usage and leaks. Go to performance tab, open the performance tab in DevTools, record the performance profile, click the record button, circle to start recording the performance profile. Interact with your Angular application in a way that you suspect might cause memory leak. This might include navigating through different views, performing actions, or running tasks. Stop recording. Click the stop button. Square to stop recording. Analyze the recording. Look for long task, memory usage spikes, or increasing memory consumption over time. Pay attention to the heap chart and event log. Memory leaks may be indicated by continuous growing memory usage or failure to release memory. Use the Memory tab. The Memory tab provides detailed tools for analyzing memory usage and detecting leaks. Go to the Memory tab, open the Memory tab, take snapshots, compare snapshots, blah 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 blah. Use again common indicators for leak when analyzing snapshots performance profiles swatches, increased memory consumption, large numbers of retained objects. Investigate common causes, unsubscribe, live-in listener timers, example walkthrough. Assume you have a component in your Angular application that you suspect is causing memory tab, blah blah blah. Compare snapshots. Okay, for following these steps, you should be able to identify. Yeah, this is how to identify. Man, some people tries to be, uh, you know, you know, sounds so smart, but actually not that smart. Um, yeah, I think that's it for memory. I'm going to sleep now. Thanks. Bye bye.